Okay, so we're back to the 2015 practice test. We're going to start with number 81. So a little more pandemic math today. So it says, what is the area of the region enclosed by the graph of y is equal to the square root of 4x minus x squared, and y is equal to x over 2. So you could go ahead and graph that in your calculator. Y is equal to x over 2 is just a line with a slope of 1/2, and the origin it goes through the origin. The square root of 4x minus x squared would look something like this. Okay, so where they cross, so you can see where you can either use the graph and do the intersection function where they cross, or you could use the solve function and just set the two equal, where you'll get more than one answer. But if you do that, they cross at 3.2. So we're looking for this area right here. And the square root of 4x minus x squared is on top. So the area will be, we're going to integrate from 0 to 3.2 of the square root of 4x minus x squared minus x over 2 dx. And your calculator will tell you that's 2.829. Right, so give that a try. And that is B. Okay, number 82. I'm going to go ahead and show you this. So this is a graph of a derivative, a graph of f prime. So we want to just go through the options here and see which of the following is true. Okay, so looking at this, part A says f prime does not exist at x equal 2. Well, yes, it does. It's right on there. There's no hole or gap there. It exists. It just happens to be at a sharp point. So that part is not true. B says f is decreasing on the interval 2 to 4. Okay, well, it's not decreasing because f prime is above the x-axis. It's actually increasing from 0 to 4 because all of the graph of the derivative, again, this is a graph of f prime, all of the graph of the derivative is above the x-axis. It's positive, so f would be increasing. The graph of f has a point of inflection at x equal 2. Well, that part is true. The slope of the derivative changes signs, and that's where you have a point of inflection. All right, so that one is true. And since only one of these statements is true, you could stop right there. You don't have to keep going, but we'll go ahead and talk about the other two. D says the graph of f at a point of has a point of inflection at 0. That is not true. Because the slope doesn't change signs there. Okay, it has an infinite slope for just a moment there, but slope doesn't change signs. And then E says f has a local maximum at x equals 0. Actually, it has a minimum there. It goes from negative to positive. And when the graph of a derivative goes from negative to positive, that's where you have a minimum. So the answer to 82 is C. All right, 80, so I'll write that in. 82 is C. 83 says a particle moves along the x-axis so that its position at time t greater than 0 is given by x of t and dx dt. So if the position is equal to x of t, then the derivative of position is velocity. Dx dt is just going to be v of t. And that is minus 10t to the fourth plus 9t squared plus 8t. The acceleration of the particle is 0 when t is equal to what time? Well, how do we get acceleration if we have velocity? Well, acceleration is just the derivative of velocity. So that's going to be minus 40t cubed plus 18t plus 8. Set that equal to 0. Solve in your calculator. All right, and when you do that, you'll get 0.831. Go ahead and try that on your own if you want, just to keep practice going with your calculator. But that is selection B. All right, so about to erase if you need to pause. Okay, let's look at 84. Says f is continuous on a closed interval 1 to 7. Okay, so it's continuous. It says that 1 to 7 of f of x dx is equal to 42. And 7 to 3 of f of x dx is negative 32. We want to know what is 1 to 3 of 2 of f of x dx. We're going to be able to bring that 2 out front in a minute. So what we need to do is kind of just fill in the puzzle pieces here. So the whole thing, 1 to 7, is 42. 7 to 3 is negative 32. Well, what that means is if I reverse the limits of integration, if I reverse that, then that negates the answer. So negative 32 becomes a positive 32. So what you would have, you could rewrite this as 1 to 3 of f of x dx plus 3 to 7 of f of x dx is equal to 1 to 7 of f of x dx. Okay, so you're going from 1 to 3, you get an answer, and then you go from 3 to 7, add those two up, and you're going to get 1 to 7. Okay, so we want to know what this is, and then we'll multiply that answer by 2 because it's asking us that value. So let's just call this x. We know that 3 to 7 is 32, and that whole thing, 1 to 7, is 42. So x is equal to 10. 2x then would be 20. So you got to be careful because one of the answers on here is 10. That's B. So it'd be easy to forget about that little 2 there. So a little bit of trickeration. So that is going to be D. Study that problem. Make a note. Come back and study that one. You need to understand this. This isn't something that we really did in our textbook. All right, we're moving along. Back to Diet Mountain Dew. Don't know if you can see that. Got rid of those Mountain Dew Zeros. Much better. 85. Let y equals f of x define a twice differentiable function. Let y equals t of x be the line tangent to the graph of f at x equals 2. If t of x is greater than f of x for all real x, which of the following must be true? What I'm going to do is just, let's think through this thing. I know that the tangent line is always bigger than f of x. Okay, so t of x is always greater than or equal to f of x. So let's just draw a pretend curve here. Okay, so we know So the tangent line, that's t of x, and this is f of x. Just making something up there. And there could be, we could have some other possibilities. How about, let's draw another one. And by the way, and that is 2. So I think that one could be a possibility too, because in that case, t of x is still always greater than f of x. So going through the options, A says f of 2 is greater than or equal to 0. Well, no. I mean, it is with this one I drew, but it's not with this one, and the bottom one is true, so A is no. B says f prime of 2 is greater than or equal to 0. Well, that's also not necessarily true. In this case, in both cases, I don't think I have a slope of the tangent line of greater than, it's certainly in the bottom one I have a negative slope. Part C, f prime of 2 is less than or equal to 0. Well, in this example I drew, that's not true. F double prime of 2 is greater than 0. What D would mean is concave up. If the second derivative is greater than 0, that means it's concave up. And both of these examples are concave down that I did. And so f double prime, E's selection, f double prime at 2 has to be less than or equal to 0. That means concave down. And that is true. You can't draw one of these graphs that has the restriction in problem number 85 that's not concave down. So the answer is E. So that'd be a little bit of a tough one. You'd have to kind of sit there and think through, and hopefully, you would have the time to do that. All right, number 86, I'm going to go ahead and fit on this board before I erase. So it says the vertical line x equals 2 is an asymptote for the graph of the function f. Which of the following statements must be false? Okay, so let's draw, and what a great vertical line. All right, let's draw an asymptote at x equals 2. Okay, it's got a vertical line, it's an asymptote. And we can draw, a graph. Got a function there. All right, so part A says that the limit as x approaches 2 of f of x is equal to 0. Well, I just really don't, if it's a vertical asymptote, it can really only be infinity or negative infinity, which is another way of saying does not exist. So A, you're starting from the beginning, A is false. And I don't see any reason, if you draw it out like that, you said, hey, that can't be 0. There's no way. It doesn't approach as the function approaches 2. And you could, of course, have it coming down this way or something like that, too. There's no way to make that thing equal 0 if there's a vertical asymptote there. So the answer is A, and you can move on. Okay, 87. So 87, they give us that fundamental theorem of calculus. And we've got a -1 to x of f of t dt. So you just, if you want to get h prime, you plug in x and then multiply by the derivative of the upper limit x, which is just 1. So what it's saying is that this graph is not only a graph of f, it's a graph of h prime. So 87 says the graph of the piecewise linear function f is shown above. Let h be h of x, and we just went through that. So it's also, this graph is a graph of f, and it's a graph of h prime. So on which of the following intervals is h increasing? Well, if it's a graph of h prime, the original function h is going to be increasing where the graph is greater than 0, where it's above the x-axis. Okay, if it's below the x-axis, it's decreasing. All right, so you just got to memorize those rules. So that's going to be between 3 and 9, and that is answer E. All right, so I hope you can tell from the video, you can see the graph well enough to interpret that. All right, 88. So it says the first derivative of a function f is given by f prime of x is equal to the sine of x squared. Which of the following do you have a local minimum? Okay, what you want to do is just graph sine of x squared on your TI-89. And you want to look at the graph where it goes from negative to positive. Okay, where does it go from negative to positive? So you can trace, you can kind of hit the trace, and since these values aren't that close together, you can just kind of get it close. That's probably the fastest way to do it, to hit trace. Or you can use the intersection or zeros, because you need to, it's going to be at a point of 0. But I think the fastest way is just to use trace on this graph. And when you do that, you'll get 2.507 or something real close to that, which is A. And the other ones are far enough away from 2.507 that I don't think you're going to confuse them. So man, that's one you can get really fast. Okay, let's see if I can fit 89 in here. It says if the limit as x approaches A of f of x equals f of A, which of the following must be true? Okay, and the first one, part A, says that f is continuous. At x equals A. Well, let's kind of draw this out. Just making something up. Let's say we have f of A and A. We've got some sort of function there. So as x, all the limit is saying, what is the y value approach when the x value approaches A? And if f of x is equal to f of A, that means there's no hole there. There's no gap. There's no jump. Okay? So if that's the case, then A has to be true. In part, if you look at the others in part B, f is differentiable at x equals A. That isn't necessarily true, okay? So, because you could have some sort of a vertical line or a sharp point there. All of the others have a possibility of a no, but A is the only one that is definitely going to be true. If f of x is equal to f of A. All right. So that is 89. Number 90 says that the temperature F is given by f of T is equal to 72 plus 118 e to the minus 0.093t for a cup of coffee. So that is a lot of information about the cooling of that coffee. To the nearest degree, what is, remember Newton's law of cooling? What is the average temperature? All right, between 0 and 10 minutes. Okay, how do we get average? Right, remember our average value. It is guaranteed that you will have to do this on the AP test, is 1 over b minus a to b, f of x dx, right? So that's going to be from 0 to 10. It's going to be 1 over 10 minus 0, or 1/10, 0 to 10, of this function, f of t. Just put that thing in your calculator. And that's 148.82. So you could round that up to 149, which is D. So boom, you are killing it. All right, you got that. And you will have to do that on the test, no question about it. Number 91, I am personally struggling with, so I'm going to admit that I'm not totally sure how to get that one. So let's skip it. The key gives the answer is D, so if you want to try that on your own, you know, maybe you can figure that out and we can have a talk about it. Okay, so, but anyway, the answer is D, but I'm going to skip it. Number 92, and maybe that's just my old age cognitive decline kicking in there. I don't know. So I'm going to go ahead and draw the graph out on 92 here. So got that. Something like that. And it says, the question says, the graph of h is shown in the figure above. Of the following, which has the greatest value? All right, so let's look at A. A says the average value between -3 and 2. Well, let's just look at that. Most of this function between -3 and 2, and I probably overdrew that just a little. So 2, -3. Most of that function below the x-axis, so that average value is going to be negative. So we're looking for what's the greatest one. The average rate of change. Average rate is going to be equal to the slope of what? The tangent line? No. The secant line. Well, the slope of the secant line, I'll put this in a different color here, is going to be something like that. Right? That in blue. So the slope of the secant line is positive, so our average rate of change is positive. See, we know B is bigger than A. Let's see what the rest of them. All right, -3 to 2 of h of x dx. Well, more of that curve is below the x-axis than above the x-axis. Okay, so if you were so this is just the area under the curve, so that's going to be negative. How about D? -3 to 0 of h of x dx. Well, -3 to 0, almost all of it is below the x-axis, so that value is going to be negative. So far the only positive one is B. Let's look at E. H prime of 0. Well, that's the slope of the tangent line at 0. And see how the slope of the tangent line at 0 is negative? So that one's going to be negative also. So the only one that's positive is B, the average rate of change, the slope of the secant line. So that completes the multiple choice for the 2015 practice test. All right, so watch these. That should help you work your practice tests, homework. Watch these videos. I will move on. I'm going to continue to do multiple choice for a while, and then we'll move back to free response, depending on the answer we get from the AP folks on April the 3rd. All right, so happy studying.